Hi, it's Sajid from UNC Charlotte. In this video, I'm going to demonstrate how SODA works. So SODA has two phases. In the offline phase, at first we analyze thousands of malware using sandbox and collect their API calls as the form of log files. Then we extract the malicious subgraph from the log file and map them to the MITRE. Then we create ploys for each of this mapping. Basically, it means we identified how to deceive a particular malware for given MSG to MITRE mapping, where we consider all the 4D deception goals and deception techniques, deception strategies we mentioned earlier, and finally we implement these ploys using API hooking. So at first I'm going to show you how MSG extraction is done and mapped to MITRE. So if we recall, a malicious subgraph represents a sequence of Win API calls that works together to perform a malicious task. The first image is the malware execution log. So when we run malware in a sandbox, we get execution trace like this, which are basically API calls made by the malware. So from these execution traces, we perform data flow analysis to build the MSGs. After the MSG extraction, we perform the MSG to MITRE mapping. So we list out the potential MITRE techniques used by this malware with probability score. So here is an example. For this particular MSG, our tool mapped it to the following MITRE techniques along with their probability score. We can get the execution trace of a malware by uploading the malware to a sandbox like Cuckoo. So in this project, we extended the Cuckoo sandbox to cover more APIs and parameters. So after the analysis, you can simply download the execution trace as a JSON file. So you can go to the export analysis and select only the reports and download it. So you can see this is the report file. So these are the API calls made by this malware. Next, we run our scripts to extract the MSG from the log file and map them to the MITRE. Here you can see we encounter an MSG like this, and then our tool was able to map it to the MITRE techniques, which are the file and directory discovery and indicator removal on the host. So which is kind of accurate, because you can see here it's trying to get the information of the file which is related to file and directory discovery, and it also deleted that file which is related to the removal of information from the host. So after mapping all possible MSGs to the malware behavior or MITRE techniques, we create this table indicating all possible deception ploys based on different deception strategies and deception goals. Then we verify and filter out the invalid combination of deception goal and strategies, and then we define the deception actions for all possible valid combination. Then we convert this table into an interface which the user will use to select his desired deception actions in the online phase. And finally, we implement these actions using API hooking, which later will be injected into malware using DLL injection. So our demonstration setup consists of three different virtual machines. So the first one with the normal background represents the user or the victim machine. The VM with the attacker image represents the attacker's machine, and the VM with the honey image represents the honey factory. So let's go back to the user machine, where we told that we will provide an interface to the user which is similar to the table that I just discussed previously from the slide. So here we provide like the IP address details of the honey factory, and like he can configure like which honey factory he wants to use, and then for different malware behavior he can choose different strategies and different deception goals, and just select this and submit this. It will save it will save a configuration file. So we load this configuration file into our implementation to understand like which deception action has been selected by the users. So at first I will demonstrate our tools capability with a vanilla rat, where our focus malicious behavior is file and directory listing or browsing. So I will show 3 different deception actions that Soda can perform to deceive this malware. So before jumping into this ploys, I would like to show how the actual malware works. So now let's come back to our settings, and in the attacker machine, let's start the server. So this is the server of the rat. So it's running and at port number 1604. So now I will run the rat client machine. So you see it's connected. Here I can go to the client information, open the file browser, and now it will take me to the C drive. So if you see here, so you can see this is what is being shown here. Now let's come back to the slides, where I would like to show you like 3 different deception ploys that we can have to deceive this malware. So the malicious behavior was the browsing the file system. So in ploy 1, we divert the malware to a false or no target by failing the malware operation. So in this case, we stop the attacker from browsing the file system. So the attacker thinks he doesn't have enough privilege to see the files, or he thinks the malware is malfunctioning. So now let's try to configure our tools so that we can deceive this malware. We go to the file and directory listing, we select the fake failure, and where the goal is diversion, and then we submit this and save the configuration file. Now we turn on our detection agent. So this is the detection agent is running, so it will detect the malware and inject our DLL file. Now let's start the malware. So you can see the DLL is injected in the malware process. Now let's try the same thing. Let's try to browse the file. Now you can see he is not seeing any kind of file. So we are actually made the process failed so that he cannot see our file system. So he will think either he doesn't have the permission to see this file system, or he will think the malware is not working as expected. Now let's go back to the other ploys. So in ploy 2, we distort the attacker by creating confusion in the attacker's mind by providing a different landing location. So in this case, we actually land the attacker on a directory that contains honey or sensitive files. Here the malware execution is successful, but the outcome is fake as the attacker is boxed to a particular fake folder. Now let's go back to our interface and configure the system so that it can have that or perform that particular deception action. So let's go back to the file and directory listing and select. So we told distortion and fake success. So we'll select this particular button and submit. So our detection agent is running. Let's restart the malware. So the malware is running and our DLL file is injected. Now let's come back to the attacker machine and try to browse the file. So now you can see the landing page is different. So previously it landed on C directory. Now we can see it's directed on another honey directory that's coming from this particular machine. If we go back to the so we can see he is currently is boxed to this particular directory. Now let's talk about the ploy number 3. In this ploy we deplete the attacker by providing him a server with never ending file system where he can keep browsing for sensitive or desired information. So in this case we actually land the attacker on a honey factory. Here the malware execution is again successful, but the outcome is fake as the attacker is boxed to a honey factory file system. Also, it's called fake execute because we actually execute these commands but just in a different machine, or like in a honey or in a honey factory machine. Now let's come back to our interface and try to configure our system with this particular ploy. And we go to the file and directory listing and select the depletion with honey or fake execute strategy. Submit and save this configuration file. Go back to the detection agent so it's running, and then we start the malware. Now let's try to browse the file system once again from the attacker machine, and now you can see it's totally different. You can see the content is coming from the honey factory. So we go to the honey factory and there is a folder name RPC, and you can see this is exactly what is being shown here, the same information. So this different deception action have different cost. For example, the fake failure is easy to implement but less likely to engage the attacker with the system to reveal their identity or the next move. In the case of fake success, it saves us the time and the cost of creating the honey factory. However, most of the responses of the fake success are static and easily can be differentiated. So the implementation cost is higher as we need to generate dynamic response to each malicious behavior. In the case of fake execute, it ensures the dynamic generation of the response to the malware behavior as we actually execute it on a machine, which is the honey factory machine. However, it adds up the honey factory creation and maintenance cost. Also, too many information exchange is required between the honey factory and the victim machine, which is also adding up the delay. So the user can choose their desired deception action based on their requirement and their costs. Now I will demonstrate our tool's capability with LockyBot, which is an information stealer where our focus malicious behavior is credential stealing. I will show two different deception actions that Soda can perform to deceive this malware. So again, before discussing the deception action, I will show you how the actual malware works. So here, this is the actual malware, and this is the attacker's machine where server is already set up. And so basically, if we run this malware, it will exfiltrate the sensitive information such as the credentials to this particular machine, which is the attacker's machine, and attackers can see those exfiltrated credentials. So let's start this. So this malware is running. Let's focus on this window to see whether any kind of credential is being received or not. Yeah, so we can see there are like three passwords, and their username and the relevant URL are already exfiltrated to this attacker. So in ploy 1, we feed the malware encrypted and invalid FTP passwords to waste the energy of the attacker who tries to decrypt and use those invalid passwords. Now let's set up our tool so that we can deceive this malware. So first we again start with our detection agent. So our detection agent is running. So first we configure our system so that we can deceive this malware. So we go to the stealing from the credential files and select the depletion, this one, and then we submit the form, and then we save the configuration file. Now we run this malware so here we can see the attacker got the encrypted and invalid FTP passwords which he might try to decrypt and which will actually deplete his resource. In ploy 2, we feed honey credential to entice the attacker to log into a honey FTP server or an account which reveals more information about the attacker such as geolocation, which we consider as discovery. The first ploy saves us the time or energy to set up the honey accounts and the honey FTP servers, but doesn't give us the option to discover the next step of the malware. The second ploy adds up the cost of creating the honey account and honey FTP server, but gives us the option to discover the next step of the malware. Now let's try the second ploy where our target was to discover the next move of the malware. So we select the honey, which is the fake execute, and the discovery, this ploy, and then we submit this form. Now we run the malware once again and our DLL is injected, and let's check. Now let's check like what kind of response we get from this malware now. Now we can see the attacker actually received the honey credential from the honey factory, and he might use this information to log into our honey FTP server or those honey accounts that will reveal his next step. So now I'll demonstrate our tool's capability with the famous ransomware WannaCry, where our focus malicious behavior is encrypting files. I will show a particular deception action that Soda can perform to deceive this malware. In ploy 1, WannaCry has a kill switch implemented inside it where it checks for whether a gibberish URL led to a live web page. WannaCry would shut down if this URL could be reached. So using this hook function, we pretend this particular website is up and running even if it's not, only to fool the malware to stop itself, hence the encryption. At first, I would like to show how this malware would work if the victim doesn't have our system. So here we run the ransomware. So we can see some of the files are already encrypted. We are waiting for the ransom note and the background will be changed. Here we go, we can see the ransom note and the details, how to payment. So now let's try the same thing with our tools being installed. So let's go back to our configuration and try to configure this deception action first. So we select, we go to the file encryption and select fake success and the diversion, and then submit this form and save the configuration. So now we run the same malware and check. Before that, we need to run our detection agent. So now our detection agent is running. So let's try to run the malware. So now we can see nothing is happening. So let's, and also in the task manager we can go and check whether this malware is running. So the malware found that gibberish URL is live, up and running, and it actually triggered the kill switch within the malware so that the malware actually quit itself. Thank you very much for your attention. I hope you like the demonstration how our tool works. So if you have any question, please reach out. I would be glad to answer your questions. Thank you.